So today we are going to discuss about numericals on springs. Already we have discussed how to derive the expression for shear stress, deflection and stiffness in case of springs. So now based on those expressions we are going to discuss about the numericals. Right? So problem on springs, a closed coil helical spring is made out of a 10 millimeter diameter steel rod. The coils having 12 turns, 12 complete turns, and a mean diameter of 100 millimeter. It carries an axial pull of 250 Newton. Calculate the shear stress induced in the section of the rod. Modulus of rigidity G is equal to 80 gigapascal. Calculate the deflection under the pull, amount of energy stored in the spring during the extension, and stiffness. So we need to calculate four. One is shear stress, another one is deflection, and amount of energy stored in the spring and stiffness. These are all the four we need to calculate. Of 10 millimeter diameter steel rod. 10 millimeter diameter steel rod. So diameter small d is equal to 10 millimeter. 10 millimeter and 12 complete turns. 12 complete turns. So n is equal to 12. N is equal to 12 and the mean diameter of 100 millimeter. So this is capital D. This is capital D is equal to 100 millimeter. What is meant by mean diameter? So now this is a top view of the spring. This is a top view of the spring. It will be just like a it will be like this. This will be the top view of the spring. Top view of the spring. So now if you see, there will be if you take this is outer diameter. This is outer diameter. Let us take D naught, outer diameter of the coil. So now this is inner diameter. This is inner diameter. Let us take this is DI. So this is mean diameter. This is mean diameter. We have derived all the equation in terms of mean diameter, capital D. We have derived all equation in terms of capital D. So now you can the relations are, for example, if you want to the relation between the DI, D naught. If you want to calculate D, that is inner diameter plus D will be the mean diameter. So this is inner diameter. Inner diameter here D by 2, here also D by 2. So plus D will give the D. Similarly, D naught outer diameter minus D will give the mean diameter. If you want to find outer diameter, D naught is equal to DI plus 2D. DI here 1D, here 1D. So this is the relation between the mean diameter, outer diameter and inner diameter. Sometimes in the problem mean diameter may not be given. So in that case you have to calculate the mean diameter. In the problem we have used mean diameter. In the expression we have used mean diameter. So you have to calculate the mean diameter, but in this problem it is directly given mean diameter. So you can take capital D is equal to 100 millimeter and load axial pull, load W is equal to 250 Newton. 250 Newton and modulus of rigidity. Modulus of rigidity is equal to 80 gigapascal. 80 gigapascal, that is 80 into 10 power 3 Newton per millimeter square. Now we can find the solution. Now we can find the solution. So first you find the shear stress. What is the equation for shear stress? We have a equation. Tau is equal to, there are two equations. One is 8W D by D cube, or we can use 16 W R divided by pi d cube. Any one equation you can use. So I am going to use this equation. I am going to use this equation because in future you will be using this equation only. But in books, this equation also used. Whichever comfortable for you, you can use. So now, if you want to find the shear stress, 8. What's the value of W? 250. 250. What is the value of capital D? 100 divided by pi into d cube. D is equal to 10. So 10 cube. What is the value? Shear stress is equal to 72.91 Newton per millimeter square. Right? So next we have to calculate the value of del deflection. When spring is, this is a spring, when the spring is subjected to a pull of 250 Newton, how much it will deflect? What will be the deflection? Delta. So we have a equation delta. Delta is equal to 8 W d cube n by g d power 4. This is the equation. You have another equation also, that is 64 W r cube n by g d power 4. You can use either this or this. We are going to use this equation. If you substitute in this equation, 8 W is equal to 250. 250. Capital D is 100. 100 cube multiplied by n. Number of coils is 12 divided by g d power 4. G is equal to 80 into 10 power 3 multiplied by d power 4. D small d is 10. 10 power 4. The value will be 30 millimeters. 30 millimeters. So now we have to find the energy stored. What is the equation for energy stored? U. Generally the equation is, whichever equation you can use, there are two equations. One is half into W into del. Half into W into del. You can use half into T into theta also you can use. Whichever is suitable for you, you can use. Now in this problem, we have the value of W del. So then you can use this equation. You can use this equation. So if you want to directly, you can calculate delta. In this equation, you can substitute the value of delta and also you can calculate. Otherwise, we can simply, you can use this equation. So half into W is equal to how much? It is 250. It is 250 multiplied by delta. Delta is equal to 30. Delta is equal to 30. So you will get how much it is? You will get 3750 Newton millimeter. Newton millimeter, because we substituted deflection in millimeter. So Newton millimeter. Generally, we use Newton meter, that is or joule or joules. 3.75 3.75 joules. 3.75 joules. So this is a unit generally we use. So finally, if you want to find the deflection stiffness, you have to find the stiffness. What is the equation to find the stiffness? That is, stiffness is equal to that K, that is equal to W by del. W by del. The same thing in this, from this equation you can find the W by del also. W by del also, but already we have the value of W and del. You can directly substitute and find. W by, what is the W value? W is equal to 250. What's the value of del? Del is equal to 30. So now stiffness is equal to 8.3 Newton per millimeter. Newton per millimeter. Straight substitutions. Straight substitution. The shear stress in the spring material is 72.91 Newton per millimeter square. Delta is equal to 30 millimeter square. And strain energy stored, that is equal to 3. That is energy stored in the spring is 3.75 joules, and stiffness of the spring is 8.3 Newton millimeter. Newton millimeter, right? So now this is second problem. This also almost similar to the previous problem. A closed coil helical spring of 10 centimeter mean diameter is made up of 1 centimeter diameter rod and has 20 turns. The spring carries an axial load of 200 Newton. Determine the shear stress. Determine the deflection when the carrying a load. Take G is equal to 80 gigapascal. Also calculate the stiffness of the spring. The shear stress, deflection, energy stored, stiffness. The same we'll discuss this problem. Design a closed coil helical spring for the following data. Stiffness of the spring is 5 Newton per millimeter. Stiffness of the spring is 5 Newton per millimeter. Solid length. Solid length is equal to 100 millimeter. Load acting on the spring is 20 Newton. The allowable shear stress is 58.3 Newton per millimeter square. The modulus of rigidity is equal to 80 gigapascal. 80 gigapascal. You are asked to design the spring. You are asked to design the spring. So what is meant by design? Design means arriving the dimension. Arriving the dimension. So how? What are the dimensions in the spring? There are mainly the coil diameter, small d, wire diameter, capital D, and number of springs. And as a spring can be specified by these three data. If you want to purchase a spring, or if you want to specify the spring, the three data are required. One is small d, capital D, and number of coil. These are the specification of the spring. So now let us find those values. So what is meant by design? Design of springs means you have to find the parameters, that is small d, capital D, and number of coils in the spring. So these are all the specification of the spring. So these are all the data you need to calculate if you are asked to design the spring. So now from the given data, stiffness K is equal to 5 Newton per millimeter. Solid length is equal to 100 millimeter, and load W is equal to 200 Newton, and tau shear stress is equal to 58.30 Newton per millimeter square. Finally, the modulus of rigidity is equal to 84 gigapascal. That is 84 into 10 power 3 Newton per millimeter square. Now, our objective is to find the small d, capital D, and number of coils in the spring. So that is design. So now, what is stiffness? K is equal to W by del. W by del. That is equal to 5. That is equal to 5. What is solid length? What is solid length? I already explained about solid length. When the spring is free, that is no load is applied, the spring will be like this. The spring will be like this. So between two coils there will be a gap. There will be a gap. When load is applied, when there is a load is applied, there is no maximum load is applied, when there is no gap between the springs. All will be close to each other. It is closely packed. There is no gap. So this is free length. We call it as a free length. So after compressed position, what is the length? This is known as solid length. This is known as solid length. Now Solid length, what is the equation for solid length? N into D. N into D. N is the number of coils. Number of coils. 1, 2, 3, 4, 5, 6, 7 into diameter. Small d. So that will give the solid length. So N into D is equal to 100 millimeter. 100 millimeter. What is the unit of stiffness? That is Newton per millimeter. Newton per millimeter. W is given, shear stress is given, everything is given. So from this solid length, we can find what we can find. We can find n is equal to 100 by d, 100 by d, and okay, this is another equation, and we have shear stress. We have shear stress equation. Tau is equal to 8 WD divided by pi d cube. So this is the equation. From this equation, what all the data are given? Shear stress is given. Shear stress is given, and we need to calculate small d, capital D. Both you have to calculate. W is given. W is given. Now what I am going to do is I am going to find D, capital D, from this equation. Capital D from this equation. If you find the value of capital D, that is equal to tau into pi d cube divided by 8 into W. 8 into W, right? 8 into W. Now, what is the value of tau? It is 58.3 into 3.14 into d cube divided by 8 into, what is the value of W? 200. It is 200. So now we can find it is 0.11 d cube. 0.11 d cube. Tau is equal to 0.11 d cube. This is another equation. So now let us calculate delta. Let us calculate delta. So what is delta? Delta is equal to 8 W d cube n divided by g d power 4. So this is the equation. So in this equation, what is delta? Delta is equal to, from here we can already we don't know the value of delta. We don't know the value of delta. So here, what is the 5? W by 5. It will come here. W by 5. So this is W by 5. Okay. So that is equal to 8. Okay. W you keep as it is W into, because here on W is there, we can cancel. Diameter cube. Diameter cube. Already we have calculated the diameter in terms of small d. We have calculated the diameter in terms of small d. Then it is 0.11 d cube the power 3 into n. What is the value of n? N is equal to, in terms of, we have a equation, n is equal to 100 by d. So 100 divided by d. 100 divided by d. Right? Now that divided by g. G is equal to 80 into 10 power 3. 80 into 10 power 3. D. Already we have d power 4. D power 4. So now in this equation, this W you can cancel. So only unknown is D. Only unknown is D. Here we have d power 9. Here we have d. Here we have d power 4. So from this, you can find the value of d. You can find the value of d. So diameter is coming 8.5 millimeter. 8.5 millimeter. Now you substitute the value of d in this equation. In this equation, here we have capital D is equal to 0.11 times d cube. So if you substitute small d in this equation, you can get capital D. Capital D is equal to 8.5 millimeter. 8.5 millimeter. Then you can find n. Here we have a equation. N is equal to 100 by d. 100 by d. Small d we have 8.5. If you put 100 by 8.5, then you will get n is equal to 12. N is equal to 12. If you get some 11 point something, then you have to round off to the whole number. Round off to whole number. That is, number of coils cannot be in fractions. So you can make it whole next whole number. So these are all the value. What we did is, we have a equation delta is equal to 8 W d cube n divided by g d power 4. So in this equation, we have substituted everything in terms of small d. Everything, g is given, W is given, del is given. Everything is given. And okay, small capital D we substituted in terms of small d. N in terms of small d. And we have small d here. So by substituting in this equation everything in terms of small d, you can find the value of d, small d. So this is way you have to solve this problem. If you are asked to design the spring, then you calculate small d, capital D, and n. These are all the data you have to calculate. This is another problem, important problem, interesting problem. Now read this. A truck weighing 20 kilonewton and moving at 6 kilometer per hour. 6 kilometer per hour. A truck is moving at 6 kilometer per hour, has to be brought to rest. It must be stopped by buffer. Buffer means springs. It is springs. Find how many springs, each of 15 coils, will be required to store the energy of the motion during the compression of 200 millimeter. So the truck is moving at a velocity of 6 kilometer per hour. The truck has to be stopped. The truck has to be stopped by springs. Must used by springs. So the energy in this vehicle is stored in the springs by compressing it to 200 millimeter. The compression allowed is 200 millimeter. The spring is made out of 25 millimeter diameter steel rod, coiled to mean diameter of 200 millimeter. Take G is equal to 94.5 gigapascal. So this is a given problem. So here the data given are a truck. This is a truck. This is a truck. What is the weight? Weight of the truck is 20 kilonewton. 20 kilonewton. What velocity it is moving? 6 kilometer per hour. 6 kilometer per hour. It is moving with this velocity. Now this is to be stopped by buffer. What is buffer? In front of this vehicle, this some springs are fixed. We don't know how many number of springs. We have to find how many number of springs are required. You got to find the how many number of springs. That's what you have to find it. So here generally we take n is equal to number of coils. Here number of coils are given. N is equal to, the springs are having how many coils? N is equal to 15 coils. It has 15 coils, and the compression delta of the spring is 200 millimeter. 200 millimeter. The outer diameter of the spring, outer diameter of the coil diameter is 200 millimeter. Coil diameter is 200 millimeter, and wire diameter is 25 millimeter. Wire diameter is 25 millimeter, and G is equal to 94.5 into 10 power 3 Newton per millimeter square. Right? So these are all the data given. These are all the data given. So a truck 20 kilonewton weight is moving at 6 kilometer per hour, which is brought to rest by buffer springs. Number of coils in the spring is 15. Deflection allowed is 200 millimeter. Outer diameter is diameter of the coil. Mean diameter of the coil is 200 millimeter, and wire diameter is 25 millimeter. Modulus of rigidity of the material is 94.5 into 10 power 3 Newton per millimeter square. Now, how to find number of spring? number of spring. Number of coil we are taking small n. Number of coil we are taking small n. I am taking number of springs. Number of springs. Number of springs I am taking capital N. I am taking capital N. Number of spring is equal to, how to calculate number of springs? We have this much of energy. We have this much of energy that is brought to rest by some number of springs. Some number of springs. So now, if you want to calculate the number of springs, okay, so energy, total energy of the vehicle, total energy of the vehicle, total energy of the vehicle divided by energy absorbed, energy absorbed by one spring, one spring. So that will give number of spring. Am I right? So here it has some energy that is stored by number of springs. If you know energy stored by one spring, if you know how much amount of energy can be stored by one spring, then you can calculate the number of springs. Then you can calculate the number of spring. So this is a thing you are going to use. So first we have to find the energy stored by one spring. Energy stored by one spring. So how to calculate energy stored by one spring? What is the equation? That is equal to half into W into del. Half into W into del. This is the energy stored by one spring. If W is the load acting on one spring. Now delta is given in the problem. Delta is given in the problem. How much it is? 200 millimeter. W is given. W is not given. W is not given. So that you are going to calculate. That you are going to calculate. How to calculate this? The W value in it is in two equations. One is tau is equal to 8 WD by pi d power cube. In that equation it is there, but shear stress is not given in the problem. Shear stress is not given this in problem. So W cannot be calculated from that equation. Another equation is delta is equal to 8 W d cube n by g d power 4. This is another equation. In that equation also W is there. You can calculate the value of W. So now here you substitute delta. Delta is given 200. Is given 200. It is 200. What is W? We have to calculate. Capital D is given 200 millimeter. So 200 cube. Number of coils. It is 15. It is 15 divided by G. Modulus of rigidity is 94.5. 94.5 into 10 power 3 multiplied by d power 4. Small d is 25. So 25 power 4. If you substitute, you can calculate the value of W. You can calculate the value of W. So W is equal to 7.69 kilonewton. So load, the force acting on the spring is 7.69 kilonewton. Right? This is for one spring. So now we substitute in this equation. Number of spring, N is equal to total energy. How to find the total energy? Half into mv square. Half into mv square divided by half into W into del. What is half mv square? Half mv square is the kinetic energy of the vehicle. Kinetic energy of the vehicle. That energy is stored in the spring. Half mv squared for one spring. So that will give N, capital N. That is number of springs. So now half into, what is the mass of the vehicle? What is the mass of the vehicle? Here weight of the vehicle is given. Weight of the vehicle is given 20 kilonewton. 20 kilonewton. From the 20 kilonewton, you find the mass of the vehicle. That is 20,000. This is Newton divided by 9.81. This will give the mass. This will give the mass. You must substitute m in mass and v square. What is the velocity? Velocity also you got to substitute in meter per second. Velocity also you got to substitute in meter per second. It is 6. It is 6. 6 into 1000. So kilometer will become meter divided by hours. It is in hours. You have to convert it into second. So if you convert into second, if you put 60, it will become minute. Again, if you put 60, it will become seconds. It will become seconds. So this is mass. This is meter per second square. Meter per second square. You can, if you put mass, the unit will be kg. Unit will be kg. If you put velocity, meter per second, that is meter square. I'm putting, you can put like this. Meter square, I'm putting meter by meter, meter. So now kg meter per second squared is equal to Newton. So Newton meter. Unit is equal to Newton meter. Energy unit is Newton meter, right? So you can substitute like this. Divided by half into, what is the value of W? Already we have calculated 7.69 kilonewton. So 7690 Newton multiplied by, here in the numerator we have energy in Newton meter. Okay. That is kinetic energy in Newton meter. So here also you have to put in Newton meter. Then delta you have to substitute in meter, not in millimeter. Delta is given 200 millimeter. So you put 0.2 meters. So this will give n is equal to 3.69. Generally, number of springs cannot be in fraction. So you round off to next whole number. It is 4. It is 4. So now here, what do you need to calculate? We need to calculate number of springs. Number of springs equal to 4. Number of springs required to stop this truck of 200 kilonewton weight and moving at 6 kilometer per hour is 4 springs. So this is a way you have to solve this problem.